I ask what the maximum force I need, because if I use million newtons, obviously it will go that way. I want the minimum amount I need for this system to move this way. So what do I know now? I know that I want the system to move that way. If I want the system to move that way, obviously the friction force will be this way. I just want the minimum force allowed, the minimum force there is that it will move. So I want the F to overcome what? I want the F to overcome, obviously, the 150 and the maximum friction, static friction that can be, which is F static max, which is 10. So the F minimum must be 160 newtons. 160, we said minimum. When I apply exactly that, the system will foo and it will move. We write 160, and it means that from 160 and higher, it will start moving. And if it starts moving, it means that the friction will not be static anymore, it will be kinetic. Now let's ask another question. What happens if I pull it with 154 newtons? What will happen? This is a question. What will happen? What happens? Okay, first of all, if it's 154, it's less than 160, obviously it won't accelerate that way. But it's bigger than 150. If it's bigger than 150, it tends to move that way. But it won't move that way because the friction won't allow it. So what will happen? The system will stay rest, won't move, and the friction force will adjust to me. So I'll have from this side 154 newtons. From that side I'll have the 150, which is this one. But I will also have how much friction force that will adjust to 154? 4 newtons. So the friction will be static and it will be only 4 newtons, not the whole 10 that it needs. What happens if I now apply 170 newtons? What will happen now? If I apply 170 newtons, it will overcome the maximum friction force plus the 150, it will overcome the 160, and it will move this way. And if I want to find the acceleration, again, I can look at each mass separately. If I want to look at the system as a whole, I will write 170 minus the friction force, but now it's kinetic because it moves. So minus 5 minus the 150 equals to the mass of the system, which is 20 multiplied by A. So this way I can find the acceleration. What happened, now another question, interesting question. What happens if I want the system to accelerate in the opposite direction? What F do I need? But let's think if it's maximum or minimum. What F do I need in order for this system to go this way? So it's another question. Let's wipe it off. I want F that the system will go that way. So first of all, I know that F must be less than 150, because if it's less than 150, the tendency will be here. And if the tendency to go will be here, the friction will be there. Now, obviously I can put no F at all, it will be easier. I can put a little higher, it will be harder. Higher, harder, 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 harder. I want the F maximum allowed for this system to accelerate, to move that way. What is the F maximum that I can apply here and the system will move that way? So, what I want is that the 150 newtons, which is this one, will overcome what? Will overcome the F static max, which is 10 newtons, plus the maximum F that I can apply. So if the maximum F will be 140 newtons, this system will start accelerating that way. Let's see a few examples. What does it mean? Let's say F is 144 newtons. If F is 144 newtons, the system will obviously want to go that way because 150 is bigger than 144, but it won't move because the friction will adjust itself. It will take 6 from the 10, and the friction force will be 6 newtons, and 6 plus 144 will be 150, and the system will stay in place. What happens when F is 130 newtons? If F is 130 newtons, obviously it will want to go this way. 150 and 130, it can't adjust anymore the static because it can adjust up to 10. So 150 and having 130, if it wanted to adjust, it needs to be 20, but it can't be 20 because it can only be 10. So the system will go this way, it will move that way, and the friction will be kinetic. If I want to calculate the acceleration, look at it as a whole, so I will write 150 minus 130, which is the F, minus F kinetic, equals to the mass of the system, which is 20 multiplied by A. And the F kinetic is 5. And from here I can calculate the acceleration. So now we know many things. I want to know one more thing. What do we know now? Let's conclude. I know that if this force, let's conclude, have a little summary. If the F is bigger than 150 newtons, the tendency of the system is to go that way, and the friction will be that way. So let's write it another way. If the F is between 150 and 160 newtons, the tendency of the system to move is this way, but it won't move because the friction force will adjust so that the system will stay at rest. If F is bigger than 160, it will accelerate that way. So it will move this way, this will stay at rest. What happens if F is between 140 and 150 newtons? It will want to go this way, but it won't go this way because the friction force won't let it. It will adjust itself, so it will stay at rest. But what's the difference between this rest and that rest? This rest is with tendency to go that way and friction this way. This rest is tendency to go that way and the friction this way. And what happens if F is less than 140 newtons? It will accelerate, move that way. Now what happened exactly at 150 newtons? Exactly when 150 newtons is applied, there is no friction because the system doesn't have any tendency to move. It's in equilibrium state without the friction. A little foo this way, it will want to move that way. A little foo this way, it will want to move that way. And then the friction will adjust itself. But exactly at 150, it won't have any friction because the system doesn't have any tendency to move. So this is all I can say about the system, all the cases that can be. So this is a very important exercise. You should try to do it by yourself and see if you get the same answers. Very important. Okay. Okay, it doesn't work out so easily. It's a waste of a lot of gigas and megas, but nevertheless, it's not my gigas and not my megas, it's yours. Okay. Let's do another one just to show you. Wow, it's 8, 9, let's say 8, I don't remember. Okay, let's do one more, a little bit more complex. Okay. M equals to 10 kilograms, M equals to 40 kilograms, mu static equals to 0.5, mu kinetic equals to 0.1. Okay, first of all, let's apply forces without friction. I don't like this one. 400 newtons, T, and 100 newtons. Now, okay, let's say I from here external F like that with an angle 30 degrees. I don't have calculator with me. That's a very big problem. A very big problem. Why did I not bring my calculator? Because I think I did. Just a minute. Just a minute. Okay. Let's write 36.87 degrees. It's a known angle. I may not need the calculator here. And let's say the force is 100 newtons. I want to know what will happen to the system. So first of all, we don't, let's move a little bigger. Let's put 1000 newtons. 1000 newtons. And let's put, okay, that's it. So, first of all, what I need to do, I don't know which way this system wants to go because I don't know the forces. I need to break this force into its components. So, let's break it. This one will be F cosine 36.87 and this one will be F sine 36.87. Now, a little knowledge from us. Sine 36.87 is 0.6, cosine 36.87 is 0.8. So it will help me because I don't have my calculator. F is 1000 multiplied by 0.6 is 600 newtons. 1000 multiplied by, sorry, that's 800. 800. And 1000 multiplied by cosine by sin is 600 newtons. Okay? Okay. Just making sure. 1000 multiplied by 0.8. Okay, that's okay. So I wipe it off. Now I want to know which way this system wants to move. This system is pulled here by 800 and pulled here by 400. Now I know that the tendency to move is that way. So automatically I know that the friction force will be here. But I don't know if the 800 can overcome the 400 and the maximum friction force that can be. So we need to calculate it. Fs max equals to mu static multiplied by n. Now the n is not 100. Look what happened here. The n is 100 plus 600. It's 700 because this force, which is applied diagonally like that, presses the mass to the ground a little more, so the normal force will be obviously higher. So this is a very good example to show you why the friction force depends not only on the mass, it also depends on the normal force. Because the normal force is much bigger than 100. It's 100 plus 600 is 700. So it's 0.5 plus, multiplied by 700, which is 350 newtons. And F kinetic is mu kinetic multiplied by the normal force, 0.1 multiplied by 700, it's 70 newtons. Now we can ask ourselves what will happen. Does 800 overcome the 400? Let's write it. Does 800 overcome the 400 plus the maximum friction force that can be, which is 350? Yes, it does. And now that we know that it does, this system will accelerate that way. And the friction will not be static, it will be kinetic. So if I want to find the acceleration, and I do, I write, let's do each mass separately. Here I write m800 minus t minus f kinetic equals to ma. That minus that equals to ma. And this one, t minus 400 equals to ma. I add them up. So 800 minus 400 minus fk equals to 50a. And again, this equation I knew because 800 is the external force in this direction. These two are the external forces on that direction, and 50 is the mass of the system. So, and fk is 70. So, I don't have my calculator, but it doesn't matter. From here you can calculate the acceleration easily. Go to the calculator and do it. If you want the tension, place the A you got and find the tension. So this is a very beautiful example to show you that normal force is not always equal to the mg. It can be adjusted easier, bigger or smaller according to the problem. Here we have this one and that one. If the F was in this direction, it would lift a little bit this mass, so the normal force would obviously be less than 100 because it presses less on the surface, and the friction, because the N will be less, the friction will be less. So we get obviously another result. Okay. Okay, let's do another last problem. 9? 9. Okay. Okay, this one m equals to 10 kilograms. M here is also 10 kilograms. Mu static equal to 0.5. Mu kinetic equals to 0.1. But I tell you another information here. I tell you that this system moves that way. Why does it move? Again, I don't know. Someone kicked it and it moves. Obviously, just by looking at it without knowing a lot of physics, it will reduce its speed and stop. And after it stops, I want to know what will happen. I want to know even more things. Let's do gradually. First of all, let's apply forces. So, 100 newtons, T, and 100 newtons. Now, I know that it moves this way. If it moves that way, I don't have to calculate anything. Obviously, the friction force will be this way, and it must be kinetic because it moves. Okay, I write F static max. I always write them because I need them for later on. F static max is mu static multiplied by n. Mu static is 0.5 multiplied by 100 is 50. Mu kinetic multiplied by n, it's 0.1 multiplied by 100 is 10 newtons. So first question I want to ask, what's the acceleration until it's stopped? Until it stops. Okay, I can look at it as a whole. Let's look at it as a whole. If I look at the system as a whole, I write 0. This is all the forces from here. Minus Fk minus 100. 0 point minus that, T I neglect because there are internal forces, equals to the mass of the system, which is 20 multiplied by A. Fk is 10, so minus 110 equals to 20A. A equals to minus 11 divided by 2 meter per second squared. So what does it mean? It means that this system will reduce its speed. Every second the speed will reduce by this number, and eventually it will stop. So after it stops, I want to know, will it move again? Now, after it stopped, something else happens. The tendency of the system to move is that way. So the friction will change direction and it will be that way. But now I need to check if the pulling force can overcome the maximum friction force allowed, that can be, which is 50. So, does 100 overcome the 50? 100 is the force that pulls the system now this way. 50 is the maximum that the friction can adjust, but it can't adjust to 100. So, obviously, 100 can overcome the maximum friction force there is, so the system will accelerate. So the F here will be kinetic, but now it will accelerate that way. And if I want to find the acceleration, let's look at it as a whole again. I will write 100 minus all the external forces here, which is Fk, not static anymore because it moves, equals to the mass of the system multiplied by A. And the Fk is 10. So here again I can find the acceleration, but now in the other direction. Okay, again, very important question, because the friction changes position. It's very important. Okay, let's do even one more last question. Okay. Similar to the one we did before, the same idea. What do you say? Let's add something up here. Okay, let's do that one. M equals to 2 kilograms, M equals to 4 kilograms, M equals to, also, no, 4 is not good. Let's say 5 kilograms and 3 kilograms. Mu static equals to 0.5, mu kinetic equals to 0.1. Okay, but I do one more thing here. I add an external force here. So again, before I ask questions, let's wipe this off. Before I ask questions, let's apply forces without the friction. So, T1, 30 newtons. T1, N, 20 newtons. T2, 50 newtons. Friction can only be on this mass because it's the only mass that placed on the surface. Now again, I don't know which way this system tends to move because I don't know anything about the F. So let's ask ourselves many questions. What's the F minimum? Before, let's find the Fs max and the F kinetic. Just we know the value, and later on we'll find the direction. Fs, we said mu static, mu s multiplied by n. Mu s is 0.5 multiplied by 20, and it's 20, it's 10. 0.1 multiplied by 20 is 2. Okay. Now let's ask the questions. First of all, if I want the system to move that way, so I want to know what's the F minimum in order for this system to accelerate that way. It's very similar to the question, to the exercises that we did earlier, but it's a good rehearsal. So, in order for this system to move that way, we look only at the external forces, the active. We neglect the passive forces, the tensions. This one is pulled by 50 here. This one is pulled by 30 here. Obviously, for this system to make it tend to move this way, I need to make sure that this force is bigger than that one. So obviously, F must be bigger than 20. So it will be 50 here and 50 here. It must be bigger than 20, but it doesn't end with this, because if it tends to move that way, automatically I have a friction force here, this way. So this F must overcome the 50, the 30 plus F, the 30 plus F must overcome the 50 and the maximum friction force there is, and the F static max, which is 10. This is the minimum force I need in order for the system to accelerate that way. The force with the 20, they help each other, must overcome all the other forces in the opposite direction. This one and the maximum of that one. So F must be 30 newtons. Let's investigate a little bit. What happened if F is 40 newtons? If F is 40 newtons, let's try. If F is 40 newtons, well, the pulling force will be 70. Here you get 50, and this can maximum give 10. 50 and 10 is 60. 70 will overcome the 60, and it will accelerate that way, as we asked it to be. And if I want to find the acceleration, let's treat it as a whole. I'll write 40 plus 30, all the forces in this direction, minus all the forces in that direction, which is F kinetic now because it moves, minus 50, equals to the mass of the system, which is 10 multiplied by A. So it will, then F kinetic is 2. So it's 70 minus 2 minus 50 equals to 10A, and A equals to, never mind. Okay. So now we know the F minimum I need in order for the system to go that way. What happens if F is between F is between 0, okay, let's ask the question. What F will make this system tends to move that way? Okay, F that makes the system tends to move that way, but still the system won't move. What do I need to ask myself? I need the F plus the, let's look at it that way. I need the F plus the 30. They must overcome the 50, and I need to just adjust my way of telling you that. Again, I want to know what F I need in order for this system to tend to move that way, but still not move. First of all, F must be, we said, bigger than 20. Oh, this is the way to look at it. F must be bigger than 20, because if it's 20, it will be 50 here and 50 here. It's bigger than 20. If it's bigger than 20, it tends to move here, but it won't move, but it still has to overcome the maximum friction force. But the maximum friction force is 10. So if it's between 20 to 30, what will happen to the system? It will tend to move that way, but it won't move because the friction force can adjust itself. So let's write, it will tend to move, want to move, what's the matter with me? Wants to move, but it won't move. For example, let's take a number from here. Let's try 23 newtons. If I apply 23 newtons, the pulling force here will be 53 in that direction. But I have here 50, this 50, and the force, the friction force, will adjust itself. It will take only 3 from the 10 and adjust itself, and the system won't move. So again, if I apply force between 20 and 30, the system won't move and the friction will adjust. If I apply more than 30, the system will move with acceleration because the friction force can't adjust itself to me anymore. Now, what happens if I take less than 20? I want to know now what happens if F is smaller than 20. So if F is smaller than 20, two things can happen. Obviously, the tendency to go is that way, but still it doesn't have to go because there is a friction. So what will happen to the friction now? If F is less than 20, the friction will change direction and it will be that way. In order for this system to move that way, I need the 50 to overcome both F, the 30, and the friction. Both F, the 30, and the maximum friction that can be in order for it to move that way. So this is 10. So F maximum will be 10 newtons. Again, what 10 newtons mean? If I apply 10 newtons, it means that this is 50, this is 40, and this can adjust the maximum and it will be on the verge of moving. If I apply a little less than 10, for example, let's do example. If let's say 8 newtons, if F is 8 newtons, I'll have 50 from this side, and from that side I will have 30 plus 8, it's 30 plus 8, it's 38. The maximum that I can get here is 10, but even if I add the 10, this will overcome those, so what will happen? The system will accelerate, and I can find the acceleration with 50 minus, it will be kinetic now, minus F kinetic minus 30 minus A equals to the mass of the system, which is 10 multiplies by A. F kinetic is 2, and you can find the A. And what happens if F is bigger than 10 but less than 20, let's say 14 newtons? If it's 14 newtons, I'll have 50 that way. I have that way the 14 plus the 30, which is 48, and the friction force will be 2. It can adjust itself to the 50 to 40, 14 and 30 is 44, and the friction will be 6. It can adjust itself to me because it has up to 10 to give. So it will give 6 and the system won't move. So let's sum up all this exercise here again. If F is between 20 to 30, what will happen to the system? It won't move, but the tendency to move will be that way. It won't move, but the tendency to move will be this way. How can I write it? Not enough room here. F between 20 and 30, rest with tendency to move that way. If F is bigger than 30, I'll have more than 60 here, 50 here. The F won't be able to adjust itself to me, so it will accelerate that way. It will move. If F is between 10 and 20, it will tend to move that way, but it won't move. It will tend to move that way, but it will be in rest. Why? Because if F is between 10 to 20, this number will be, with 30, will be between 40 to 50. So this 50 will overcome, but the friction will adjust itself because it has up to 10 to give. And if F is less than 10, this number will be less than 40. So the 50 will overcome the less than 40 and overcome the maximum friction that can be. So the system will start accelerating that way and it will move. Okay, again, a very important question. I hope you understand it. The most important thing about this question is that the friction force can change direction according to the tendency of the system to move. And F controls which way the tendency is to move. If it's bigger than 20, it tends to move here. If it's less than 20, it tends to move here. And then the friction force comes into action. Okay, I think we did everything. Let me see. Okay. I think it's fine. Okay, next lesson we are going to deal with slopes and friction. It's very similar to that. And after that, it will be fine. We'll have many other things to do. So, thank you.